Hi there. In this project, I'd like to show how we can use Responses API from the OpenAI. Before this, I had only seen methods that used an HTTP node, but it turns out there's actually a built-in node that handles this task. The project is quite simple, so we'll create a basic node for entering a chat message, and then we'll select the built-in AI node from OpenAI labeled Message a Model. Next, we'll select the model, for example, ChatGPT Mini, the simplest one, since we don't need anything complex here. To test the model, we'll write a simple message like Hi. Okay, we will stop the node and connect our input for an initial test. We've set up the chat input, and so let's send another test message. After receiving a response from the model, we'll check the logs to see where this message is located. On the responses logs page, we can see that the message is indeed there. Perfect. This means we're using the Responses API, not the Completions API, like the regular AI node that runs on LangChain. Now we need to set up a system for storing chat history. We'll use the built-in DataTable node for this. We'll perform an upsert row to create and update the chat record within a single session whenever our AI agent returns a message. We use upsert row so that if there's no history for the session yet, it creates a table entry, and afterward it keeps updating it with the current chat. So, we'll create our table and add additional columns for the session ID and the message history. Now let's configure our inputs and pass in the session ID and the messages. We'll specify that one message was received from the user and a separate message was received from the AI agent. Next, we'll map our table so updates happen only by session ID, fill in the value in the table, and check whether a row appeared. Yes, great, we can see the row is there. Now we need to set up fetching this chat history before sending messages to our model. We'll use the same data table node to get the record by session ID. Since the record is always updated with the latest chat, we can limit the query to a single row. We can see we've retrieved the message and how it works. Let's connect our main AI node, our agent node, and slightly tweak the initial prompt history. We'll refresh since an intermediate node appeared, and add a system message where we'll pass our chat history. We'll also note that this is chat history and set the value coming from our table. Time to test. We'll send, Hi, my name is Ilya. We can see the entry with our question, and the model's answer is saved in the table. Now we'll ask, what's my name? To verify it remembers correctly. Perfect. The chat history was passed through, and now the model understands what we talked about earlier. Now let's compare how tokens are used with different approaches. We'll open our latest message generated in n8n and check the token counts. We can see 45,000 tokens in the input and 79,000 tokens in the output. Next, we'll simulate the same chat in the playground. We'll create a new chat, select the same model, keep essentially the same settings, and send the same messages. Now let's look at token usage in the playground. The output is roughly the same number of tokens, while the input is slightly lower. Most likely, this difference comes from the fact that we marked the chat history explicitly as history in the system message. Overall, the difference is small, and this approach is perfectly usable. What personally interests me about this method is that by using this kind of node, we gain access to built-in tools and a wide range of settings provided by the Responses API, which we can experiment with and test further down the line. Of course, this setup still needs improvement. We clearly need a better message storage system, more reliable passing of the retrieved chat, and cleaner row updates. But overall, as a starting point, this project is usable. I hope you found it interesting. In the next project, I'll try to expand on using the Responses API by building a multi-agent system and exploring how the built-in settings work, since this approach allows us to use them. Thank you for watching. See you in the next videos.